Howdy guys. So in this video we're going to be taking a look at creating digital assets inside Houdini. Often referred to as HDAs, Houdini digital assets are models which retain their procedural properties inside of Houdini and can be exported into other programs such as Maya, Unreal, Unity, so that procedural assets can be used from Houdini inside those programs. Oftentimes HDAs can even be created to perform a custom function that would otherwise require multiple nodes in Houdini. And you can save these HDAs and modify their properties as you need later. So with that in mind, let's get started using an asset that I've chosen. So we're going to be making a barrel in this video. I just got some quick reference images, so we'll probably make end result will probably be something like this. Probably not going to model the rivets; those can probably be done with a texture. Quick diagram breakdown of the different parts. And so when starting off with the barrel, we'll probably start doing the staves individually first because they make up the core chunk of the barrel, and this even shows us how to make the head at the top. So let's get started. So first off, I'm going to start with a tube, and I'm just going to name that barrel, and we're going to go inside. And okay, so a tube starts out as a primitive type. Let's make it a mesh, and then we're going to want the center to be up. So let's go ahead and copy the height and paste that relative reference over here and multiply it by 0.5. You'll notice in most of these videos and when I'm doing references like this, I multiply by half rather than dividing by 2. And that is because due to the way that computer architecture tends to work, multiplying is always faster than dividing. So now we're going to have this tube is going to be the basis for our barrel staves. We can control the height right here. That'll be used later to control the initial height of the barrel. Let's go ahead and increase the rows here a bit so that we can get some of the bends and the staves, and increase this columns. Let's go ahead and just do 100. That'll be fine. We definitely won't need more than that. And we can always change this later. Alright, so now that we got that, let's go ahead and start converting this into an HDA. So we're going to go back up to the top, and I'm going to select our node and hit Shift C to subnet it. And then I'm just going to call this barrel HDA. And now that it's a subnet, we'll right click it and go down to create digital asset. And then when we do, we can name it. I'm just going to call it barrel HDA, and here it will just be barrel. So this operator name is what Houdini references internally. If you were to try to access this HDA through a script, this is the name that it would look for. The operator label is how it appears in the text label boxes and inside Houdini and other programs. When saving to a library, let's choose, probably, we'll just go up to my barrel demo directory over here. Just paste that there. I'll just call this barrel.hda, and we'll hit accept, and then this type properties window will appear. The type properties window is how we create our own user interface and parameters for our barrel HDA. We can even update it with a custom icon if we would like. We might do that later. The save to library path where we saved the HDA, this is the file where the HDA is. The HDA is an independent file that we are editing now inside of Houdini. This is different than a HIP file. A HIP file is a scene file. A scene file can have multiple HDAs embedded in it. So again, HDAs exist completely independently of a HIP file. So for example, if we were to file save this HIP file right now, it would save this, but if we made changes to our HDA, those would not be saved in the HDA file. Those would exist only in the HIP file. Alright, so these are the default parameters here, this transform, and we don't need these, so I'm just going to select them and then make them invisible. And then we'll hit apply, and we'll get a clean slate over here. And we can always see these again if we just show invisible parameters, if for whatever reason we need to see them. But we don't, so they can stay invisible. So, over here we have all of the types of parameters that we can add to our HDA. So if we go down into here, and we have our tube, we need a float parameter to control our height here. So let's go ahead and take a float, and we'll just drag it over here. And we're going to name this parameter height and label it height. And it's type float. A neat thing about Houdini and the parameters with the digital assets is that we can go here and change it from a float to an int if we need it, or vice versa, and we can do this at any time. And we'll hit apply and go back up, and here we have our height parameter. So here we can just copy this parameter and go down to our height and paste that relative reference, and now we'll see this ch://height. This is the path to the variable name. Notice it is height little h down here that we're referencing in Houdini. And so now we'll just apply and accept. And notice it's at 0, so our height is 0, but you'll see as we drag this up, then our barrel will grow. And that's the basics for setting up parameters for digital assets in Houdini. But now let's go ahead and look at what we can do here. So let's right click and go to type properties, and this will open up the type properties window again. We can go ahead and look at what options we have for this height parameter. So what we were going to want to do is notice that when our height goes down to 0, our barrel ceases to exist basically. So we can actually set the minimum maximum values of our barrel here. So we can check this range box and lock this lower value, and we'll say that let's see, I don't know, 1 is a pretty good minimum value. That's our shortest barrel. We'll say that 5 is the maximum height of our barrel. So what we can do is if we apply this and let accept, then our slider has updated so that 1 and 5 are our maximum and minimum ranges. But because we didn't lock 5, if we wanted to type 6, then we could. And then our range would still be down to 5, but it would allow for a user to input custom things if they want. Notice if I try to do 0.5, it's going to reject that and lock it back down to 1. And that's because we, in our type properties, have locked this minimum parameter. I'm going to go ahead for now and lock this up maximum parameter as well. We'll hit apply to lock that in, and then we're going to go ahead and make some other parameters here that I know we're going to need later. So we're probably going to want another float, or let's say an int. Yeah, let's grab another int, and we're going to call this num staves, and then number of staves. And then we're going to give this a range, let's say minimum of 8 and a maximum of 20. And I'm just kind of making these numbers up as we go. And we'll hit apply. So notice both of these, when we make them, are set to minimum by default. And we can look at that if we go to the channels, and here we can set our default values. So I'm going to say that 10 is probably a good default value for my staves, and now our default has updated to 10. We can do the same thing for our height, and I'm going to say that 2 is a good default barrel height. We'll hit accept, and we can right click this parameter and say revert to defaults, and it will hop over to 2. Alright, so now that we got that, I'm going to go ahead and split this window in half real quick so that we can get a better view and I can link our parameters over. I'm going to go ahead and pin this window Well, real quick, let's dive down. So notice when I dive down that both of my windows update to display whatever my currently selected node is. But if I pin this window and then I dive down, I can keep this window up here, so that my HDA properties, as it were, and then my node properties over here on the right. And this makes it really easy to copy parameters and then paste them over here. So now that we have a tube, let's start looking at creating our staves. And so we're going to do this using the carve node. What the carve node does, and you'll notice if we look in here, it's basically a tube with a carved piece out of it. So it will allow us to carve a piece of this tube out for us. And we're going to turn on the first and second U, so we have two pieces. We're going to carve from the beginning and the end. And we're going to say we're going to start our carve from the very beginning. Notice this is a range of 0 to 1 as it moves around. So 360 degrees normalized for a value of 0 to 1. So 1 being 360 degrees fully around the circle. And so what this will do is allow us to control the width of our staves. And so we could do this in a couple of ways. One, we could control the stave width and just say that the stave width determines the number of staves that we have, or I would prefer to do just to know the number of staves that I have. And so when we're trying to do this, we're probably going to want to take the number of staves, and we'll just paste that right there. And now it's going to maximum to 1 because this node's max is 1. It can't go higher than that. So what we can do is go ahead and I'm going to open up our expression editor right here. I'm going to do 360 degrees divided by the number of staves. And we'll apply that, and notice that's not going to do anything because our value that this will return in this case 36, so 360 divided by 10. And this would work if our maximum range here was from 0 to 360, but because it's from 0 to 1, we're going to have to once again divide this by 360 to normalize that value. And now we'll see that we have a range of 0.1. And actually, since we're doing 360 divided by num staves divided by 360, the 360s will actually cancel out, and so we can simply just do 1 divided by the number of staves. That makes that expression nice and clean. So just the inverse of the number of staves that we have. And now we'll see, as the number of staves increases, the width of our staves will decrease. And now let's go ahead and look at some of our node properties. If I middle mouse click on here, I can see that we have one mesh, and these are our vertices and points. And Houdini is considering all of this one primitive and one mesh. And that would be fine, except for some of the operations that we're going to have to do later, we're going to have to be working in polygons. So we can just drop down a convert node, and then we'll just convert this to polygons. And then we'll notice now we have 110 polygons and 110 primitives. And that is for all of these faces right here. So now for revolution purposes, we're going to need to center this stave on this x-axis right here. So we can just drop down a transform node. And then on this transform node, rotate it around its pivot to about half of its maximum width. And so to do that, we can take the carve amount here, and we'll paste that here. And this is going to be 360 degrees and probably negative. Okay, so that's mirroring it. So really we just need 180. Gosh. See, I just can't type in here when you can't see where the cursor is. So apply. Alright, there we go. There we go. So now, as our number of staves changes, it will stay centered on our x-axis. So now that we have that, let's go ahead and look at poly-extruding our staves and then duplicating them around and making our barrel. Let's go ahead and rename some of these real quick. So here we're carving out our stave. We're converting to polygons. And here we're just recentering our staves. Alright, so now let's go ahead and add some thickness to our staves. And we're just going to do that by poly extrude. And we'll go down to there. I think probably 0.075. That'll be thick enough. Let's go ahead and add that output back. And now we can start duplicating these around. Go ahead and name this thickness. And we'll add a duplicate node. And we're going to call this revolve staves. And now that we have that, our total number of staves that we want to duplicate is going to be here. So we can just copy our number of staves and paste that there. So it's going to look like we have one, but we'll see that if I add some transform on here, we'll get all 14 of our staves right here. And that's offsetting it by a distance of 0.5 for every single copy that we have. So what we want to do instead of translate them is we want to rotate them around the pivot so that we get a nice circle. So we'll zero that out, and then we'll see when I start trying to add some rotation here, they're all rotating around the center pivot of the object, and that's right here. So let's just go ahead and change that pivot to 0. And now you'll see that when we rotate them around, we get something like this. So deciding the degree that we're rotating each of our staves through is pretty easy. Really, we can just do, we're going to want something like that. And getting this number, we can just take 360 degrees divided by the number of staves. So we'll do 360 divided by our number of staves. And now we'll see that lines up pretty nice. We should probably go back to our poly extrude and add a little bit of inset there just to separate the wood on the staves a bit. That looks good. Let's go ahead and make this a little bit bigger. Alright. So now that we have that, let's go ahead and drop these this stave into its own group, and we'll keep working from there. So I'm just going to subnet this and call it stave. And then we can dive into there, and now we have just our stave. And so now we can make changes inside this node network, and then the output of that will revolve around according to our duplicate. So let's go back up to the top, and let's add a new property for the stave bend, or the bow amount. Let's go ahead and add a new float. We'll call this bow amount. There. Good range for this. Let's see. Let's say a min and max of 0 in case we want a straight barrel, and 0.5. And we'll set the default of this to something like 0.25. And just do like halfway in between. Work. And let's hit apply. And now we have our bow amount right there. So let's go ahead and copy that right there and go back into our stave. And we can actually probably add our bow before our poly extrude. So let's drag this guy down. And what we're going to want to do is select the middle points right here. And we can do that with a quick group node, because we're going to want to select these middle points and then pull them out and have the rest of the stave transform with it. So we're going to want to select the middle points right here. So in order to select these middle points right here, to bow them out with a soft transform, we need to make a group. And then inside that group, we're going to select points. We can turn off the base group, and then we're going to want to keep by a bounding region. And we'll get this box, and you'll see as we move this box, it'll start highlighting the points that are inside that box. So we just need to set the parameters so that that box will always select the middle points here. We're going to want the size in the Y direction to be pretty small. Let's go ahead and grab the height from here, and we'll paste that down there, and we'll say that's times 0.25. Okay. And then for the center, we're going to want this to be right around here. And we're going to want this to be long enough to get that area right there. So if we just center this like that, so let's go ahead and make this actually like 0.2. We'll make it thinner. Alright, so that'll work. But now if our height changes, this isn't going to work. So we're going to need the center here to change based off of our height. So what we can do, if we go back to tube 1, I'm actually going to name this stave base. We can take the bounding box of this, our base stave, and grab the Y maximum height of that bounding box and then half it so that we can make sure that this will always be in the center of that bounding box. So to do that, we're going to type a very short and simple expression. We're just going to bbox, and we're going to go quote dot dot slash to go up, and then we're going to find stave base, and we'll end that selection, and then we're going to do dy max. And then now we'll see it's going to be always at the top, and so we actually need to do times 0.5. And then as our height changes, it will always select those 2 points right there in the middle. Alright, and now let's go ahead and call this group center points. I'm going to go ahead and make my group node yellow, just so that it's easier to see. Let's make it blue. Alright, so now we're going to add a soft transform to our stave. And with this soft transform, we want our bow amount to control how much our bow is moving. So if we see here, this transform will move our object this way. And so what we want to do actually is select our group for center points. And now as we move this, only the center of our stave will move. So you'll notice right here we actually are only getting part of our thing. We really want this to go from all the way to the top and the bottom, and we can move this by changing the soft radius to a higher value. But again, this value is going to change based off of how tall or short our barrel is. So this is again going to have to be linked by our height. So what we can do is just grab our height parameter, and we'll paste that here. And we're going to want this to be about a little less than half, so we'll do 0.44, something like that. Let's say 49. And that way, as our barrel height changes, it doesn't move our top points. It actually might need to be like 0.8. And we'll say this is a quadratic fall off, so we get a nice smoother arc. And they're still moving a little bit. Let's make this 0.44. There we go. Alright, so now we have a nice bow on our staves. So now if we go back to our poly extrude, we can see it's extruded our staves. Let's go ahead and link our bow amount to there. That looks good. And then we can step up and go to our revolve. And there we go. So we'll notice we're going to need to scale the middle points again to thicken out our staves. So if we move this out, let's go ahead and pin this and move up. So let's see, something like this. That looks good. But now when we make our barrel taller or shorter, that seems to work, but as the number of staves change, it looks like that's also working, but if we change the bow amount, everything breaks. And now we get this weird overlap here. So we can fix that by writing another quick expression. And to do that, we're going to say actually going to have to do some math, and we'll be right back while I do that. Alright, so now that we've got that, our bow amount changes and the middle scales, and our number of staves can also change along with the height. And yeah, to recap, if we go back to our soft transform, this is the expression and equation that I made to make that soft transform amount happen correctly. I had to do this using a technique from linear algebra known as Cramer's law, and a little bit of matrix math, and I can go over how to do something like that in a future video. Alright, so that's about it for our let's just call this stave bow amount. And alright, so that's about it for our this first video. So we've got the makings of a good barrel HDA right here. We can control the height, the number of staves, and our bow amount. In the next part of the video, we're going to add the tops and bottom, as well as the bunghole and some of the barrel rings. And yeah, so I'll see you in the next video.